A thin slice of raw tuna lands on a piece of rice, gets picked up with chopsticks, and disappears without a second thought. No fire touched it, no pan, no heat, nothing. Millions of people order this every single day without a flicker of hesitation. Now say the words raw chicken out loud, and something in the room changes. Raw pork sounds even worse. Even raw beef, which plenty of people genuinely do eat, still arrives with a warning label and a very specific, almost ritualistic set of rules attached to it. So why does one feel completely unremarkable, and the other feels like a direct route to a hospital bed? It turns out that gut reaction is running a far more sophisticated calculation than most people give it credit for. And the real answer has almost nothing to do with fish versus meat. It's about exactly who is trying to survive inside you and how well equipped they actually are to do it. Before getting into the biology, it's worth clearing up a common assumption. Eating raw fish isn't some recent culinary trend. Coastal communities have been doing this for an extraordinarily long time. Archaeological evidence from Japan points to raw seafood consumption stretching back thousands of years, long before the word sushi existed. Peru's ceviche tradition, using citrus acidity rather than heat to prepare fish, goes back centuries among coastal populations who had no other reliable way to preserve a catch. Raw fish isn't an indulgence. It's one of the oldest methods humans have ever used to eat protein. Start with the fear most people actually have about raw fish: parasites. Anisakis is a small worm that lives in the muscle tissue of species like salmon, cod, and mackerel. Swallow a live one and it can burrow into the stomach lining, causing a condition that brings on cramping, vomiting, and occasionally an emergency room visit to have it physically removed. That sounds genuinely alarming. Except sushi-grade fish almost never causes this problem, and the reason is refreshingly unglamorous. Regulatory standards require fish intended to be eaten raw to be frozen first, either roughly 7 days at standard freezer temperature or around 15 hours at a much colder commercial temperature. Freezing kills the parasite outright. Every reputable sushi restaurant on the planet is running its fish through a freezer before it ever reaches a plate. An entire category of danger gets solved by a box that makes things cold. Not every fish carries identical risk either. Freshwater fish tend to host a wider range of parasites than saltwater species, which is part of why traditional raw preparations lean so heavily on ocean fish rather than river fish. Salmon sits in an unusual middle ground since it splits its life between fresh and salt water, which is exactly why farmed salmon, raised in controlled parasite-free conditions, became the reliable default for raw preparation rather than wild-caught salmon. The ocean isn't universally safe. It's simply safer in the very specific ways that happen to matter here. Now compare that to what actually makes raw meat risky, and the entire story changes. It isn't really about parasites at all. It's about bacteria, specifically about which bacteria happen to be exceptionally good at surviving once they get inside a human body. Raw beef and raw poultry commonly carry E. coli, Salmonella, and Campylobacter. All three evolved inside the gut of a warm-blooded mammal or bird. Your gut is also warm. Human body temperature sits right inside the range these organisms are built to thrive in. A cow, a chicken, and a human are all running roughly the same internal climate, which means bacteria adapted to live inside one of us are frighteningly well equipped to live inside the rest of us too. Poultry makes this pattern especially clear. Campylobacter alone causes well over 1 million illnesses a year in the United States, and undercooked chicken is one of its most common sources, one of the most consistently reported foodborne illnesses tracked by public health agencies year after year. That consistent documented history is a major reason raw chicken triggers such a strong, near-universal aversion in a way raw tuna simply never does. Fish don't share that disadvantage with us. A cod spends its entire life at a water temperature that would give a human hypothermia. The bacteria that colonize a fish's gut are cold-adapted specialists, drop most of them into a 98.6-degree human intestine, and they simply can't compete. It isn't a hospitable environment for them. They never evolved for it in the first place. Disease ecologists actually have a name for this underlying pattern: the phylogenetic distance effect. The basic idea is straightforward. Pathogens jump more easily between closely related hosts. A pig and a human share an enormous amount of underlying biology, which is exactly why raw pork carries such a brutal reputation. Trichinella spiralis, the parasite behind trichinosis, moved through pork for centuries before modern farming and inspection standards largely eliminated it from commercial meat across most of the developed world. Earlier generations didn't need a microscope to know something was wrong with raw pork. They simply watched what happened to the people who ate it. In the United States alone, trichinosis infections numbered in the thousands annually through the early 20th century, tied largely to undercooked pork and raw sausage. It took a combination of stricter farming practices, feed regulations, and sustained public health campaigns to push that number down to the small handful of cases reported today. That fear didn't appear out of nowhere. An entire generation lived through the consequences before the safeguards caught up. Fish, evolutionarily speaking, sit about as far from humans as any common food animal gets. A salmon and a human split from a shared ancestor roughly 400 million years ago. A cow and a human diverged far more recently than that. Whatever lives inside a salmon has had 400 million years to become extremely bad at surviving inside a human. Whatever lives inside a cow simply hasn't had nearly as much time to lose that ability. Push that same rule to its logical extreme, and you arrive at the most dangerous meat a person could possibly eat raw: primates. Bush meat from chimpanzees and gorillas has been directly linked to some of the deadliest documented cross-species jumps on record. HIV is now understood to have originated from a chimpanzee virus that crossed into humans through exactly this kind of contact, likely decades before anyone recognized what was happening. When the animal on the plate shares nearly all of a person's own DNA, there's almost no biological gap left for a pathogen to cross. There's a cultural layer to all of this too, and it's worth mentioning because it undercuts the idea that avoiding raw meat is some kind of universal human instinct. Plenty of cultures eat raw beef without any hesitation at all. Steak tartare in France, kibbeh naya in Lebanon, yuko in Korea, carpaccio in Italy. None of these are fringe foods. They're centuries-old dishes served in serious established restaurants, which means the aversion to raw meat isn't hardwired the same way something like an aversion to visibly rotten food tends to be. It's learned, regional, and shaped heavily by whichever food safety disasters a given culture happen to actually survive. There's an even sharper example of this further north. Inuit communities have long eaten raw and fermented meat from seals, whales, and caribou, foods like muktuk and quack, despite these being mammals far more closely related to humans than any fish. On paper, that should carry more risk than raw beef. But the animals involved live their entire lives in near-freezing environments, which keeps their bacterial load radically different from anything found in a warm feedlot animal. Evolutionary distance isn't only about the family tree, it's also about the temperature an organism grew up in, which is exactly why the fish story and the Arctic story end up pointing at the same underlying rule from two completely different directions. Psychologist Paul Rosen, who spent much of his career studying disgust, has argued that food aversions function less like fixed instincts and more like inherited warnings. A culture gets burned by something once, badly enough, and that caution tends to stick around for generations, even long after the actual risk has largely disappeared. American discomfort with raw chicken traces back to a real, relatively recent history of salmonella outbreaks. Japanese comfort with raw fish traces back to an equally real history of coastal communities safely eating it for thousands of years, carefully refining exactly which cuts, seasons, and preparation methods kept people alive. So the fish was never actually safer than the meat in some absolute universal sense. It's safer for very specific, very traceable reasons. Cold-adapted organisms that struggle badly inside a warm human body, a single freezing step that eliminates the one parasite that actually matters, and a 400 million year evolutionary gap that keeps most fish pathogens from ever getting comfortable inside a person. Raw beef and raw pork carry an entirely different category of risk, not because the meat itself is inherently worse, but because the organisms living inside animals biologically close enough to humans can cross that gap almost trivially. Warm blood recognizing warm blood, which means the next time you're deciding what to eat raw, that gut instinct isn't superstition. It's picking up on something genuinely real. Not a simple rule about fish versus meat, but a much older rule about distance. This has been the Reasonary, where curiosity meets clarity.